no, go to the third server on a different IP. And each of those times you get different ports, and that gave me accurate data. So that was cool. Mail. I needed to get mail into the picture. And this was a bit of an evil stunt. So what I would do was I would generate a random mail address and tell people to, hey, go send an email to this and leave this web browser open. Now what would happen was the user would send the email, maybe through Exchange, maybe through whatever. That would hit SMTP. SMTP would hit DNS. DNS would hit my little Perl script, which would go ahead and generate a file, which would end up getting picked up by a web browser that was polling for that file. So you should not try to wrap your mind around the HTTP to SMTP to DNS to HTTP to HTML bridge that I had to write for all that to work, but it did. Left undone was a bit of a stunt that I thought would have been a lot of fun. I was considering allowing people to embed a tester into their own blogs and websites. A couple people actually asked for this. Problem was that no one would actually ever support script sort, and hi guys, I'm a hacker. Could you please embed my JavaScript into your online bank? Let's talk about things that are not going to happen. So I had to come up with a solution, and the solution was actually the Billy Hoffman plan. This was fun. So web browsers are very, very restrictive on what information they will allow to flow cross-domain. Unless you go, script source to some other domain, and then it'll let anything happen. But the online bank did not want to have to trust me. They wanted to get a little bit of information out of me, whether the server was insecure, DNS server was secure or insecure, but they absolutely did not want to run my code. So how do we do this? Well, there's one really small, and by really small I mean a couple of bits per HTTP request, that allows scripting. It doesn't allow scripting across sites, but allows a few bits to move cross-domain, and it works on all browsers, and it's the image size of an image, which can be loaded cross-domain. You can't get access to the pixels, but you can find out, was that a 1x1, a 2x2, a 3x3, a 4x4? So I find this and I'm like, man, this seems like something Billy would have worked on. And oh yeah, the dude wrote like an entire tunneling library over it. He's like telling me, oh yeah, PNG gets really annoying when you get these dimensions. You have to go to XBM, but that doesn't work in Netscape. But oh my God, that's weird with these. Dear God, man. He's like, wait, you found a use for that? I will use this stunt for a future thing, but I thought I'd document it. Maybe there's something you have for it. So now what? What do we do now? Well, we're at about 75%. We're not getting better anytime soon. There are no numbers yet on what percentage of users are actually protected by the 75% of name servers. So you could have all the users because all the major ISPs. You could have a couple of tiny, few name servers that have like 100,000 users behind them. We don't have measurement yet. Do we keep going? Are we done yet? No. All the bugs are still there. I mean, all the software I described is still broken. It's just we've kind of taped over the problem a bit, and not particularly effectively by the one fix from 1999. So, DNS is not alone, guys. There have been at least 4 bugs this year that have exposed content which for some strange reason is trusting that its gateway has not been compromised. DNS bug was one. The BGP bug was another. The SNMP v3 bug was a third. And then how many of you guys saw the WPA2 break that was at PACSec a few months ago? Yeah, what happens when you break into a wireless LAN? That means you're on the LAN. You are the gateway now. And there's going to be more. Now, I said earlier, I believed DNSSEC can actually be a help for this. Question is not why DNS was insecure. Of course DNS was insecure. It was designed in 1983. Question is why everything else, things that were designed like last year, why those things are insecure and what we're going to do about it. So I got a few thoughts. First off, the present deployment numbers mean nothing. DNS, like all the authoritative server modifying solutions, needs the root signed for the solution to at all be meaningful. No one's going to go ahead and do any work to deploy something that has no actual use in the field. And if you can just go ahead and attack the parent because the root isn't signed or COM isn't signed, you're done. Now, XQID thought that they had a way around this whole root and COM poisoning issue. Doesn't work. You can come find me later if you want to hear the gory details. Now, the root has remained unsigned in DNSSEC for far too long. That's apparently going to change. I apparently have something to do with that. Apparently, the big thing in the DNS world right now is automation. How do we make key signing just happen? Look, DNS scales. We know that. We've seen it do it for 25 years. DNSSEC in its normal operating mode, not so much. You know, there shouldn't have to be talks about how to deploy DNSSEC. You should install the latest version of Bind and be done with it. Now, that doesn't mean that's entirely going to work. There are some fundamental requirements that make that difficult. But we really do need to get the deployment story of DNSSEC as close as possible to source port randomization. We also need to figure out how exactly we're going to interact with the registries and registrars. These are the servers that ultimately consume data to put it into the global shared namespace. These systems have no idea that DNSSEC exists, and they need efficient and elegant ways to find this data out. We need to ease the business load on them as much as we need to ease the management load for the end administrator. Now, what about DNS Curve? You guys heard about this? DNS Curve is DJB's alternative solution to DNSSEC. Be another about 3 minutes. DNS Curve is interesting. I think we have a lot to learn from it. It's based on link-based crypto instead of anything that can actually be cached. What's good? First off, it just says, look, you're going to have your signing key online. The original thinking of DNSSEC was that you only updated your DNS records every once in a while, and you can have like the key in a signed vault and all this crazy stuff. It was never going to happen, especially not in 2008 with the rate at which we move things around. The model is far too dynamic, and admins are far too harried for offline keys sort of make sense. So DNS Curve just says, forget it. Let's see what we can do, assuming that a signing key is online. The other nice thing, the really nice thing in DNS Curve is that registrars don't have much to do. All of the chaining of security is based on the actual names of name servers. So here's what doesn't work. Well, first off, there's no code. Okay, that matters. The second problem is that it requires new crypto. You know, Dan Bernstein doesn't think that much of RSA. You know, ECC is standard, but his proposed curve is not. I mean, it's a curve optimized for speed, which is about the last thing I want to hear when it comes to the safety of a crypto system. And it's not actually that fast. I want to repeat all of those. It's not proven, it's patent encumbered, and it's not specified. It is cool. It is totally cool. No, look. Performance matters. DNSSEC was designed to not require per-query crypto operations on an authoritative server. That means if you've got a record and you're the server for COM or Google or whatever, you sign it, you return it. You're not doing crypto every time someone asks you a question. With DNS Curve, every time someone comes up to you, you got to be like, oh crap, I got to go ahead and unpack another DNS Curve blob. Okay, I got to go pack up something new. How expensive are these crypto operations anyway? Well, they're relatively fast, but, you know, DJB's sample code, I went ahead and ran it. I'm on a laptop that has capability of doing about 15,000 DNS queries per second. It can do maybe 10,000 ECC operations per second. We got to do 2 ECC operations per second for a DNS Curve operation. That means you're spending 100% CPU at 1/3 the load. No one is going to deploy this. Now, it could possibly be optimized faster, but why? You know, the larger issue, and this is the thing that I consider the fatal flaw in DNS Curve. And remind you, I have nothing but respect for it, and I think we have a lot to learn from the proposal. But there is no way to ever achieve end-to-end trust with DNS Curve. With DNSSEC, we can envision ultimately clients that do their own validation using the name server infrastructure just to cache. In other words, your desktop actually is validating every single record to see, do I have a chain from the root? And it doesn't increase load because all that stuff still uses the caches inside every name server that's out there. Well, DNS Curve says no. You don't get security unless you are directly interfacing with the DNS infrastructure. That means your stuff can't be cached. That means no one can say to you, I have validated this information, and if you'd like to see it yourself, here's what I used to validate it. Because the validation secret is not in your hands anymore. So there are two possibilities. You either abandon end-to-end trust, meaning all these applications that need to get secured don't, or you abandon caching, meaning there's a 100 times increase in the amount of DNS load out there. Okay, DNS can't absorb 100 times increase. So it has a lot of cool things. I really, really like. There's a lot of DNS curve that can actually be absorbed into DNSSEC that's going to make people unhappy, but it's the right thing to do. We have more to learn, but I don't think it's the right approach for the time. So a couple conclusions. No, we're a bit over. First, federation is hard. Everyone's been using DNS to do it. That DNS is not secure has not been stopping people from doing it. And authentication has suffered. But authentication has been suffering. It's a mess out there. DNS offers potentially a way to fix this. It is at the core of so many systems that putting a fix here has effects above and beyond. And finally, I have just one more thing. I'd like to point out that when I poisoned that name server, that Drupal installation at the beginning, that was frontend.doxpera.com. Meaning there's a backend.doxpera.com that it was getting its database from. Well, it was getting its database from until the point that I poisoned DNS. And now I had the front end going off over the internet, making a MySQL connection to my backend. Okay, we got to fix this stuff. We really do. That's what I got. Can I take questions? Okay. So thank you much. I'll be around for questions outside, but they need the room now.